Yeah, so let me take a look at this. Okay, sorry, give me a moment. I'll just set up because one of our teammates has gone with his Zoom, so I'll take over his presentation instead.
All right, no problems.
Yeah, hi everyone. Welcome to our presentation. So our focus here is physical enablement. We designed a walking aid to guide the elderly to use walking frame properly and also prevent fall. So first of all, we have our team. It consists of myself, Weihan, Ibrahim, and Nicholas. So our project is called a Smartwalker, which is a walking stick augmented with sensors and components to enable smart features. So walking can be a challenge for elderly and patients in need of rehabilitation. Walking assistance devices such as the walking aid are used in the rehab process for these users. Sorry. Yep. Okay. Our task is to enhance the rehab of users and the caretakers by augmenting this walking frame with sensors and components and smart features, and also safety features such as object detection and user guidance. The team paid several visits to AWA, which is in Ang Mo Kio, to gather information from different types of walking assistant devices and understand the usage of requirements of such devices so that we can tackle any problems that might be faced, such as environmental obstacles. We also explored how often patients spend time at the AWA Rehab Center, and as such, the devices will be used at both the center and at home as part of their recovery process. So to tackle this problem, we worked with AWA to come up with solutions first. We came up with a bill of material. These materials include the quad walker and 6 ultrasonic sensors, 1 light sensor, 2 pressure sensors, and 1 infrared sensor, and possibly an MP3 speaker to play messages in various languages or even dialects. The devices placement are as shown on the diagram on the right. Let me see.
Okay,
Yeah.
Yeah, to tackle these problems, we worked together with Ava to come up with some solutions. First, we came out with a bill of materials, the previous slide.
Yeah.
Yeah. Okay, so these are the quad walker itself, 6 ultrasonic sensors, a light sensor, 2 pressure sensors, 1 infrared sensor, and 1 MP3 speaker. So the device placement on the walking frame is as follows. Next slide. Okay, so for number 1, right, we have object detection to ensure the path of the user is clear of obstacles, which is at the leg there. And number 2, step guidance with sensors is to provide a systematic guidance for users with walking difficulties. Number 3, pressure sensor ensures that the user is holding the walking frame correctly to commence the other features. Number 4, infrared sensor checks if the user is within frame and not outside. And we also have a night light that automatically emulates the direction of the path when the environment is dark.
Next, we have looking at some zoom in to see what is the features of our walking stick. So we have this pressure sensor to check for users when they are using the frame properly. So this other sensor will check for the user presence. And then we have the step guidance lights to point at the floor whereby they will take the step at this location. Then this is the sensors to make sure that they have taken the right steps. And also this is the heart and the brain of our Arduino-based system. Then our system is powered by power bank at the moment, but we have development to use future development plans to use more efficient and lighter power sources so as to be easy on the elderly. Then these are the LED lights which will light up the environment. And these are 4 ultrasonic sensors that will check the surrounding of the walking frame to check for obstacles. Next, I'll pass on to a demonstration of a walking frame. Yeah. Can you all see the video?
Hi guys, my name is Esther.
Hello, my name is Nicholas.
Hi, my name is Ibrahim.
Hi everyone, my name is Weihan and we're from Team CAAN.
Our team was put to the task of designing a smart walking frame that helps the elderly get through their rehabilitation phase safely. With information we gathered at the AWA Rehab Center, we devised an Arduino-based solution that is our CAAN Smartwalker. It has features such as user presence detection, obstacle detection, illumination in darkness, and step guidance. This ensures that the elderly users stay safe during their rehab session as well as at home. There are other features still being developed such as fall detection, audio messages, remote alert with phone app via Bluetooth or RFID.
Our device comes with an array of microcontrollers, sensors and transducers to support the planned features. The project uses an Arduino Mega mounted onto the body of the frame, along with 2 pressure-resistive sensors, 1 on each handle, an IR sensor facing the user, 4 ultrasonic sensors for object detection, with 2 on each front leg to detect objects in front and by the sides. 2 additional ultrasonic sensors to detect steps, which work with 2 LEDs by the side for spotlights. We have also implemented a light intensity sensor interfaced with a separate Arduino Uno to control ambient lighting for usage in the dark. Demo time. The user begins by standing within the walking frame before holding onto the handles. The audio feedback prompts the user to begin walking by first pushing the frame ahead. The spotlight on the left prompts the user to extend their left leg. Then once a left step from the user is detected, the next spotlight, different colored, lights up on the right to prompt the next step. This loop repeats to help users get acquainted with a regular walking posture. But wait, there's more! Here's a standard household obstacle, the dustbin. Esther will now test the obstacle detection feature.
Okay, as user move forward, obstacle is detected. So walker will warn the user. So when the obstacle is removed, walker goes back to normal. Yeah. So object is detected on the side. The red LED will not turn on. It will be just the warning tone.
We have limited time, so we'll skip to the end. So we have special thanks to our professor in SIT, Prof. Dan, and our professional officer, Ms. Kong, and our mentor, Mr. Tan, and of course our representation from AWA, Ms. YY. So do you have any questions for the team, please?
All right, thank you to the team. There's actually a question from the audience about the device might actually be a bit complicated, but I think from your video, it was quite straightforward with all the sounds, all the lights and all. Do you have anything else to add on for this?
Actually, the usage is quite straightforward with the guiding lights. They will shine on the floor in sequence to guide the user to walk properly with the walker itself. So it's actually quite easy to use.
All right, thank you for that.
Yeah,
I see that your device is really well thought out and so much more than a regular walking stick, like a walking aid. Actually has pressure sensors to make sure they're holding it correctly and even obstacle detection and all. How did you come up with all these features, or like were there any challenges that you had in this process?
The main challenge is weight. Actually, at first we thought of asking my uncle to test because he's blind in one eye and he had polio, so he had limited usage for one leg, which is very ideal for this walker itself. But then due to COVID, we are unable to make that happen. So we actually listened to AWA's guidance of the elderly who go through their centers and go for rehab. So from their experience, we developed these the solutions for our worker.
All right, so perhaps more testing with the end user would be appropriate, right?
Yeah, sure.
All right. Any key takeaways from this project, from this learning process?
Yeah, we actually learned the hard way how to collaborate as a team to develop such a complicated project. And our time schedule in our degree is actually not helping at all, because this trimester we are quite busy actually, multiple projects going on. So we hope that by doing this project we can learn better about all this embedded system, and as well help the elderly in our community. Thanks.
All right, thank you to Team CAAN for their presentations, and thank you to all the teams for their wonderful presentations this morning. I see that all of y'all have had challenges with time management and all, but you have done an excellent job in coming up with solutions that meets the end user's needs.